Robot structural analysis gives you the ability to define several different types of loads for your structures. Once a structure is modeled with claddings, you must then define the load types the structure will encounter to ensure the model can withstand various environmental factors. To begin, from the text menu, select Loads, Load Types. The Load Types dialog displays. In this example, 5 loads will be defined. In the Case Description group, expand the Nature drop-down. Select Dead, and then click Add. The list of defined cases updates to include the dead structural load. The load type is automatically assigned a number and a case name. Now expand the Nature drop-down again. Select Snow, and then click Add. Again, the list updates. In this example, 2 wind loads are added to account for wind blowing from the left of the structure and from the right of the structure. Expand the Nature drop-down. Select Wind, and then click Add twice. This adds 2 wind loads to the list. Finally, the last load type to be defined is the Live load. Expand the Nature drop-down, select Live, and then click Add. Next, select the number that corresponds to the dead load. An arrow displays indicating that the dead load case is active. Click Close to exit the Load Types dialog. Now, the weight of the roof cladding needs to be added to the dead load case. To accomplish this, from the text menu, select Loads, Load Definition. The Load Definition dialog displays. Open the Surface tab and select the Uniform Planar Load. The Uniform Planar Load dialog displays. In the Values group, in the Z field, enter -0.13. Select Add or press Enter to add the load. Now, back in the Load Definition dialog, define which cladding the load is to be applied to. Upon creating cladding, each cladding is assigned a number. The number can be found by either selecting the cladding in the drawing area or by viewing the list in the Object Inspector. From the Object Inspector, expand Claddings and select all the claddings in the list. Next, in the Load Definition dialog, click within the Apply To field. The field updates to list the range of claddings. In this instance, the claddings are assigned the numbers 135 to 139. Click Apply and then click Close. Next, define the load case for snow. From the toolbar, expand the Cases dropdown and select SN1, the name for the snow load. From the vertical toolbar, select Load Definition. The Load Definition dialog displays again. Once more, the snow load case will be a Uniform Planar Load. Open the Surface tab and select Uniform Planar Load. The Uniform Planar Load dialog displays. In the Values group, in the Z field, enter -0.24, and then select Add or press Enter to add the load. The snow load will only be acting on the roof cladding. To apply the load, in the Load Definition dialog, select within the Apply To field, and then, in the drawing area, select the roof cladding. The numeric value assigned to the roof cladding displays in the field. In this instance, it's 136. Click Apply, and then click Close. Next, define the load cases for wind. The wind loads are defined as constant loads on wall panels and a contour load on the roof panel. In addition, wind loads must include both windward and leeward intensities. The definition of wind load cases uses the local coordinate system. To begin defining the first wind load, from the toolbar, expand the Cases dropdown and select Wind 1. Next, to verify the orientation of the local Z-axis on the claddings, open the Local Systems dialog by selecting View, Display. The Display dialog opens. From the sidebar, select Model, and then, from the window, expand Local Systems. Check Local Systems of Panels and Cladding. Click Apply, and then click OK. Arrows display in the drawing area, indicating how the panels are oriented. All claddings should be oriented outward. In this example, the gable wall is oriented inwards. To change the orientation, select the cladding, and then from the text menu, select Geometry, Properties, Local Panel Direction. The Local System Orientation dialog displays. Check Change of Local Z-Axis Sense, and then click Apply. The arrow on the cladding updates to indicate an outward orientation. Use the view cube to rotate the model to ensure all panel orientation is outward. Change any orientation that indicates inward using the Local System Orientation dialog. Once the orientation of all the claddings indicates as outward, from the vertical toolbar, select Load Definition. When defining wind loads, you will need to define a pulling pressure or positive load and a pushing pressure or negative load. Open the Surface tab and select Uniform Planar Load to open the dialog. In the Z field, enter -0.39 for the pushing pressure. In the coordinate system, select Local. Click Add. Back in the Definition dialog, click within the Apply To field and select the Windward panel, which in this case is the far left cladding, number 138. Click Apply. Open the Surface tab again. Select Uniform Planar Load, and then in the Z field, enter 0.01 for the pulling load. Select Add. In the Load Definition dialog, select the previous panel number in the Apply To field, and remove the value. Then, in the drawing area, select the leeward or far right panel. The panel number displays in the Apply To field. Click Apply. Again, from the Surface tab, select Uniform Planar Load. Enter 0.05 in the Z field, and then click Add. In the Load Definition dialog, select the previous panel number in the Apply To field and remove the value. Then, in the drawing area, select the gable wall that is visible, and from the Object Inspector, select the other gable wall. The panel number displays in the Apply To field. Click Apply. Now, from the Surface tab, select Uniform Planar Load on Contour. In the Z field, enter positive 0.56. Again, under Coordinate System, select Local. Next, select Contour Definition. Now, in the drawing space, select 4 corners to apply the load to 1/6 of the roof structure. Click to place the points in succession, ending on the initial point selected. The coordinates for the points list in the Contour Definition window, and the Uniform Planar Load on Contour dialog closes automatically. Again, in the Load Definition dialog, remove the existing value in the Apply To field. In the drawing space, select the roof, and then click Apply. The Contour Definition needs to be repeated for the middle third of the roof. Again, from the Surface tab, select Uniform Planar Load on Contour. In the Z field, enter 0.13. Select Contour Definition, and then in the drawing area, select 4 corners to apply the load, again placing the points in succession and ending the selection with the initial point. Since the roof is already selected, in the Load Definition dialog, click Apply. Finally, define the contour for the remainder of the roof. From the Roof Surface tab, select Uniform Planar Load on Contour. In the Z field, enter -0.20. Again, select Contour Definition, and in the drawing area, select 4 points to define the remainder of the roof. Again, since the roof is already indicated in the Load Definition field, click Apply. Click Close. To inspect the load case, from the text menu, select View Display. From the Display dialog, from the menu, select Panels. Expand Filling the Interior, and then deselect Cladding Interior. The interior of the cladding in the drawing space becomes invisible. From the views, enable the load symbol and load value descriptors. The values for the load cases display in the drawing area. Next, to define the second wind load, you would need to repeat the process with the following load case data for a uniform planar load. For the windward wall, the Z field needs -0.48. For the leeward wall, the Z field needs 0.01 added. For the gable walls, the Z field needs 0.05 added. Uniform planar loads on contour would need to be defined for the roof as well. Again, defining 3 of the same sections of the roof for the windward 1/6 of the roof. The Z field would be set to 0.65. The adjacent 1/3 of the roof would be set to 0.16, and the remainder of the roof would be set to 0.24. Next, set the live load as the active case. From the toolbar, expand the Cases dropdown and select LL1. From the vertical toolbar, select Load Definition. The Load Definition dialog displays again. Open the Bar tab and select Bar Force. The Bar Force dialog displays. In the Values section under F, in the Z field, enter -10. Click Add. Back in the Load Definition dialog, select the Apply To field, and then in the drawing area, select the first rafter and right-click. Now, from the menu, click Select Similar, select by cross-section. All rafters are selected. Click again in the Apply To field for the numbers of the rafters to populate. Click Apply, and then click Close. Now that all loads are applied, you can inspect each one from the toolbar. Expand the Cases dropdown and select the Dead Load. The drawing area updates to display the selected load case. Expand the Cases dropdown again and select the Snow Load. Again, the drawing area updates. Inspect each load to ensure it is accurate. Finally, to display the load table, from the text menu, select View Tables. The Tables, Data, and Results dialog displays. Check Loads and then click OK. From here, you can inspect and modify the loads. From the bottom of the window, click Cases to inspect the load case definitions.